I welcome you all to the session of engine system and performance, and our today's discussion is on the modern engine management system. As such, in last few classes we have discussed about engine system, several components of engine system, then we have talked about several engine valves, engine other accessories, then thermal management, other heat transfer from engine block, which is broadly energy management in engines. So, today we shall discuss about a topic which is very important topic for this particular course, that is engine hardware, that is engine management system. You know that in earlier engines everything used to be controlled by mechanical systems. Say for example, if we need to supply fuel and also air, because without air fuel mixture we cannot have combustion, and if we need to ensure efficient combustion, stoichiometric air fuel ratio should be supplied. Now, question is, depending on the load demanded by the engine, either we need to go for fuel enrichment. So, if we need to supply fuel enrichment, supplying fuel enrichment or adequate fuel or even rich fuel in the air fuel mixture using any mechanical system is not so fast, will not be reliable. Even for any mechanical system, mechanical component, there will be some time lag or delay. So, to this end, electronic control unit, which is also known as engine management system, provides a more flexibility. So, today we shall discuss about what is an electronic control unit, and then if time permits we shall go for its description, illustrating unit or ECU, and we will see then how does that particular unit control several inputs essentially to monitor air fuel mixture and also spark advancement and also temperature of air which would be supplied into the engine. So, to start with, let us discuss about what is electronic control unit. Electronic control unit, in short it is known as ECU. So, we shall be referring to this or using this word frequently. This is also known as engine management system. I am underlining these words. From the name engine management system, you can understand that this system is solely responsible to manage entire engine operation through electronically. As I said you that if we need to control everything using any mechanical arrangement, mechanical components, then there will be a time delay, and accounting for the time delay, precise and very fast adjustment of anything, be it control of air temperature, be it very fast supply of fuel or even relatively higher rate of fuel supply to the engine, all these things may not be possible instantly. To this end, electronic control unit or engine management system provides a greater degree of flexibility. So, now what is electronic control unit? So, the function is, so this system ECU or engine management system, its function is, or primary function, rather primary objective is to coordinate several subsystems. What are those subsystems? So, basically engine management system controls or coordinates several subsystems. Those subsystems are inevitably attached to the engine for their better performance, smooth operation and ensuring maximum efficiency. So, that means primary objective of engine management system or ECU is to control or coordinate several other subsystems so as to ensure smooth and safety operation of engine, provide maximum or better efficiency, ensuring reduced emission or control emission. So, these are the objectives. This is the primary objective. Now, question is, the primary objective is to coordinate several subsystem, right, so as to basically that is in order to adjust torque generated by the engine. So, this is the very first requirement, because essentially we need power output, right. So, even if we need to go for maximizing the power output at the cost of the compromisation of other things, like compromising with the emission that would be there from the engine, compromising with the fuel intake. So, compromising with all these things, if ECU is solely designed to adjust torque generated by the engine, then again it will not be wise or design or meaningful design of the system. So, that means ensuring maximum amount of torque that we are expecting to obtain from engine, that should be the first or primary objective. At the same time, or we need to ensure there are many other functionalities to be ensured simultaneously. What are those? So, those are basically some other functionalities are to control emission in line with standard, standards certified by the environmental agencies or board. So, that means that we have some sort of reservation or restriction so as to maintain, reduce or permissible limit of emission. So, that part also should be accounted for when we are trying to design or we are designing ECU. So, ECU or engine management system is designed not only to provide maximum power output by adjusting torque that would be developed by the engine, but also to ensure that fuel emission should be in line with the standard, rather laid down standard by the environmental agencies or board. Second, number 2 is certainly to control fuel consumption. As I said you that if we are really targeting for maximum power output, and for that if we need to compromise with the fuel consumption, that would be ill design of engine management system or ECU. So, that is important. Number 3 is certainly which is the primary objective, that is power output optimum, I am writing in bracket. Number 4 is, that is to ensure safety and comfort. So, basically this safety is very important for any type of engine, be it a stationary engine or be it any automobile engine. Now, for automobile engine we also need to ensure that the comfort should be there. That means that if engine is operated by mechanically moving or mechanically driven components, which used to be the cases for earlier engines, that operation should be jerky, operation will not be smooth. In that case we have to compromise with the comfort level. So, this is also very important. Safety is equally applicable for both stationary engines and automobile engines, but comfort is really important for the automobile engines. So, these are basically simultaneously the simultaneous requirement from electronically control unit or engine management system. So, this is what we have written. Now, question is this electronically or electronic control unit, right. So, as I told you, electronic control unit, which is very reliable piece of element, I should say, or system, very reliable, because if we know some requirement from any other from several components of engine block, say for example, if we demand more load from engine, and engine must know that to meet the demand we have to supply adequate amount of air rich with fuel. So, that requirement if it is instantaneous, so engine should fill the need of that instantaneous requirement of adequate or extra amount of air rich with fuel. That should be very fast and also smooth. ECU, electronic control unit, is a very reliable piece of system that can serve that purpose. So, which is not really possible using any other mechanically driven or mechanically moving components. So, let me write here at that will help you to understand better, that ECU is an extremely reliable piece of hardware which is capable of receiving, and simultaneously processing information very fast or promptly. So, that is what I was discussing. That means, if any demand arises instantly, engine management system or electronic controls unit should be able to collect the need and also to process the need very fast or promptly. So, that is why this is very or extremely reliable hardware. Now, if it is so, we also need to know about its structure, but we shall be discussing about this unit, that is electronic control unit or engine management system, illustrating a schematic depiction of this particular unit. Before doing so, let me just briefly mention here that heart of ECU. So, heart of ECU is the microprocessor, right. Heart of ECU is the microprocessor, right. So, in ECU essentially microprocessor is the heart of an ECU, which will wherein inputs received from the engine will be interpreted and output commands will be issued promptly. As I told you that if the requirement of air to be drawn into the engine is more than what engine is supplying at any instant of time, then input should be given to the ECU, and receiving that input, ECU should transform or process that particular input and give an output signal to the sensor which is placed at the intake manifold that please open or widely open the throttle valve. So, that way engine can control the requirement of air to be drawn into the engine cylinder. Similarly, I can give you another example. Say for example, if it is a CI engine, if it is a SI engine, then nowadays all SI engines are having separate fuel injector, but earlier engines we had discussed carburetor used to play an important role. So, even if we consider a SI engine is having a carburetor, and if the requirement of charge or air fuel mixture at any instant of time of engine operation is more than what the engine is getting, then that input signal will go to the ECU. ECU will process that signal, immediately supply an output commands to the sensor, which would be placed in the carburetor so as to supply more amount of air fuel mixture by adjusting the throttle valve, by adjusting other units of carburetor. So, say another example I can give you, if it is a CI engine and instead of supplying more amount of air, if we need to go for enrichment of fuel, that keeping the amount of air or mass flow rate of air intact, if we need to supply more amount of fuel, then certainly taking input from the sensor which would be there in the fuel injector, that input signal will go to the ECU, and if the requirement is more, certainly that speed control sensor will be there. So, speed control sensor will sense that yes, engine is now experiencing higher load, that input will go to ECU. ECU will give immediately an adequate output to the fuel injector or fuel nozzle to supply more amount of fuel. So, that way everything is controlled so precisely and nicely and as well as promptly, which is not possible using any mechanical or mechanically moving component or system. So, this is what is ECU. Now, basically this microprocessor will receive input, immediately interpret that input and will give output commands so as to adjust several other auxiliary systems, and engine will meet the need or requirement at that particular point of time of its operation. Okay. So, that means what we can understand that receiving input microprocessor, that is the heart of an ECU or engine management system, will transform or will interpret that signal, process that signal and immediately give some output commands. So, that processing the input signal, transforming that input signal into output command and certainly sending that output commands to another subunits of engine, this entire process can be subdivided into a few categories. Let me write down all those categories here. The process and output functions of the ECU, electronic control unit, can be divided into the following areas. So, number 1 is, let us now discuss about a few areas. One is fuel injection control. That means, input signal might come from several areas or several blocks, several units of engine. Receiving input signals from several units, that engine management system, that is centralized, that is very responsible to receive all units from engine and will ensure a smooth and safety operation of engine. So, engine electronic control unit or engine management system might receive input signal from fuel injection so as to control fuel injection. That means, that the example that I gave you, if we need to go for fuel enrichment, certainly we need to control fuel injection, that is by controlling the gap or by controlling the opening area of fuel nozzle, we can control the fuel that should be supplied into the engine. So, fuel injection control. Number 2 is spark advancement control. So, you can understand spark advancement control is certainly pertinent to an SI to SI engines, because we need to go for spark retardation or spark advancement. Probably you have studied in your undergraduate internal combustion engine course that we need to go for spark retardation and spark advancement, so as to control the combustion rate, right. So, this is also possible, rather all these flexibilities should be integrated, or the engine management system should have all these flexibilities. Then number 3 is engine speed control. I also gave this example that if an automobile engine or if a stationary engine is or experiences high load, then speed will reduce. If speed reduces, then ultimately that volumetric efficiency is function of RPM. So, volumetric efficiency will reduce and then combustion may not be adequate. Then eventually to meet that high load, or when engine will experience high load, a situation might arise when engine will stop. So, that means some control also would be there inside the ECU, so that when engine speed reduces experiencing high load, some input signal will be received by ECU and then receiving that input signal, ECU will process and again send some output commands to other auxiliary system like air fuel mixture, fuel injector or carburetor, or to supply more air. So that it would be more combustion and then more power output would be there. So that the speed would be again restored or speed will remain the same. Then 4 is emission control, which is also an important part for engine, and then 5 is failure management. Failure management. So, this failure management we shall be discussing this part little after today. Now, so all these are basically the process, that means ECU or engine management systems should have some arrangement or some provision so as to receiving signals from all these 5 areas. ECU would be able to process those signals and would be able to send some output commands immediately, ensuring smooth and safety operation of engine. Okay. So, if you go to the next slide. So, now what are the functions performed by the ECU? So, that means let me write here the functions performed by an ECU. That means, if we need to go for fuel injection control, if we need to go for spark advancement control, if we need to go for engine speed control, if we need to go for emission control and finally failure management. So, it might so happen that at the same time we need to go for fuel injection control as well as emission control. So, to accommodate all these, the function performed by an ECU should be well defined, well guided. So, let us now write what are the functions performed by an ECU. Number 1 is generation of an electrical signal that is to be sent to the injectors, rather I should say fuel injectors. Number 2, generation of electric ignition signal. Number 3 is spark advancement, controlling signal. Number 4 is basic pulse with calculation and refinement. Basic pulse width calculation. What is the role of pulse width, that we will discuss in this module even. Basic pulse width calculation and refinement. Okay. Number 5 is closed loop control. closed loop control of the engine based on feedback from EGO, which is exhaust gas sensor. Right? Why it is needed? As I told you that electronic control unit or engine management system should be able to or will have the capability of controlling emission. So, that means one sensor should be there in the exhaust manifold sensing or receiving some input signal from the exhaust manifold. There will be a closed loop control unit, so as to maintain the emission level like temperature of exhaust gases, NOx emission and many other things, so as to maintain or so as to compliance with the requirement of environmental standards. Number 6 is enrichment of mixture, certainly fuel air mixture, in case of strong positive throttle variation, right, which is needed, perhaps you have studied during cold start off and engine warm up, right. During cold start up and engine warm up, we need to go for greater degree of throttle valve control. During that time, enrichment of fuel air mixture should be controlled by the electronic control unit or engine management system. And then number 7 is to trigger exhaust gas recirculation system. This is also known as EGR, exhaust gas recirculation system. Why it is needed? Perhaps again you have studied in your undergraduate internal combustion engine course that we need to recycle back exhaust gas in a turbocharging unit. Recycling the exhaust gases, if we can run a small turbine, and the work output from the turbine would be able to run a small compressor, and by running that compressor we can increase the pressure of the intake air. So, the entire unit is known as turbocharging. Question is what would be the temperature, what would be the pressure of exhaust gas that comes out from the combustion chamber also should be monitored or triggered. So, engine management system should be capable of triggering this part as well, right. So, now question is, these are the functionalities of engine management system, right. So, are these only functionalities which an ECU or engine management system will be having, or if I can pose the question that only these are the functionalities we should expect from an ECU or engine management system. No, beyond this another important functionality or function an ECU or engine management system should have. What is this? See, as of now we have discussed that engine management systems will receive signals. Signals from where? signals from different sensors. Sensor will be there in the intake manifold to sense air temperature of or intake air temperature. Sensor will be there in the exhaust manifold to sense temperature and pressure of the exhaust gases. Sensor will be there to sense even engine speed. Sensor will be there in the fuel injector to know whether we need to go for controlling the opening area of the nozzle so as to supply more amount of fuel or not. Sensor will be there in the water jacket, cooling water jacket, so as to sense the temperature of the coolant. So, all these sensors are very important for the efficient operation of ECU or engine management system. Now, sensors might malfunction. So, keeping the provision that sensors will not work or at a given point of time, because any system cannot run for a longer duration, and if any sensors start malfunctioning during engine operation, then what would be the case, what would be the situation. Now, I can give an example. Say if engine needs to supply or needs to give more load, more power output, and to obtain more power output than its design capacity, we need to supply more amount of air or more amount of fuel. Now, the question is, if the sensor which will give some input signal to engine management system towards the requirement of more amount of fuel to be supplied by the nozzle, and if that sensor is not capable of supplying that input signal, then what will happen. So, that means considering the possibilities of failure of sensors, adequate measures should be taken by the ECU, and which is very important to know. At this point of time, let us discuss that part. So, that means to take into account the possibilities of sensor failure, some preventive measures should be taken, and we shall be discussing all those preventive measures now, and those preventive measures should be taken by ECU. To have all these preventive measures, to ensure all these preventive measures by an ECU, by an engine management system again will be having some other subsystem or subcomponents. So, if we write now that additional functions to be achieved by ECU. So, these additional functions are to be achieved by an ECU only to take into account the possibilities of sensor failure. Okay. Thus, I am writing very quickly. One is deactivation of the closed loop control in case of absent or incorrect signal of EGO. EGO, that is exhaust gas sensor, right. So, if EGO is the sensor which is there in exhaust manifold, if that sensor is giving input signal or if the sensor is absent, that means as if sensor is not virtually present. Maybe sensor is present therein, but it is not working. So, in this case, deactivation of the closed loop control should be needed from ECU. Number 2 is deactivation of the EGR, that is exhaust gas recirculation system in case of EGR failure. We have discussed about the need of recirculations of exhaust gas. Number 3 is trigger of the fan in case of a signal failure from the coolant temperature sensor. As I told you that cooling water jacket will be equipped with one sensor, and that sensor would be solely responsible to give some input signal to the ECU about the temperature of coolant, whether the coolant is receiving adequate amount of heat from the engine block or not. If that sensor start malfunctioning, if the sensor is giving input signal, then ECU will give some output, or it will trigger a fan to operate immediately, so as to reduce temperature of engine block, engine cylinder. Okay. Then if we go to the next slide, 4 is stop the engine by shutting down the fuel pump in case of failure of any of its critical sensors. Of its means of ECUs of engine management system. So, if any critical sensor of engine management system fails, then ECU should have adequate arrangement so as to give some signal to the engine to stop the fuel pump, and eventually engine will stop. And number 5, which is very important, that is replacement of default value of faulty signals, generated from temperature sensor. Basically, which are needed for coolant and ambient air. Right? If a sensor fails, the engine control system, is still able to maintain engine operation. Engine control system or engine management system. Okay. So, this is important. By how it does, we shall be discussing later when we will be discussing any particular type of control system. So, this is very important, the replacement of default value of faulty signals generated from any sensor, from temperature sensor, may be coolant and ambient air. If a sensor fails, then engine management system is still able to maintain engine operation. So, by how it would be possible by the ECU or by engine management system, we will discuss this part again in detail. Now, question is all this thing, that means a control system, essentially engine management system is engine control system. So, that system is having a few will receive a few signals, receiving signals, that microprocessor will process all those signals and then transform some output signals. So, basically this control unit, so engine management system or engine control system. So, we have seen the requirement or objective or functionalities of an engine management system, and considering the possible failure of sensors, there will be again certain preventive measures, and that preventive measures should be taken by the control system. Therefore, a control system or engine control system should have a few tasks. So, if we now write that a control system should, number 1, perform its function properly. Number 2, respond should respond quickly. Number 3, should be stable, and number 4, respond only to valued inputs. Respond only to valued inputs. What does it mean? Noise immunity should be there. So, if it receives, if engine management system receives noise, receiving noise, engine management system should be able to filter that noise. So, only it will respond subjected to valued inputs. So, if we would like to summarize our today's discussion, we have discussed about an electronic control unit, which is also known as engine management system. Then we have discussed about briefly what are the functionalities of an engine management system should have. To have all these functionalities, what are the requirements, circuit, all these things we will discuss in our subsequent classes. And since engine management system, which is known as electronic control unit, which you also can call engine control system. So, that means it should have the provision of controlling several aspects like speed control, spark advancement control, emission control, exhaust gas recirculation control, and fuel enrichment control. So, to have all these controls, it should be very precise and it should be very reliable as well. And thereafter, we have discussed that essentially engine management system or electronic control unit will receive a few signals and from sensors. Now, sensors might start malfunctioning. So, in such a case, again some preventive measures should be taken by the electronic control unit or engine management system, so as to ensure a smooth and safety operation of engine. So, with this I stop here today, and in our next class we shall be discussing about this engine management system, illustrating a schematic depiction of several units and several blocks. Thank you very much.